Welcome to Mitchell Maths. In this video we're going to have a look at trigonometric graphs. The first graph we're going to look at this video is y equals sine x, and you will be expected to be able to sketch the graphs of sine x, cos x, tan x. So if we want to draw the graph of sine x, well, the sine x graph does start at 0, 0. And I like to split it into 90-degree segments. After 90 degrees, it changes by a value of 1 up to 1, because the graph goes up and then it starts to go down. If I go 90 degrees along, it changes by 1 each 90 degrees. So as it starts to go down, it'll go down from 1 to 0, passes through 80. And it's going to drop down again by 1. So 270, it goes to -1. And then it goes back up to 360. So I'll try to draw the curve the best I can on this whiteboard. So it goes up to here. Then it goes down to 180. Then it goes to 270. It hits -1, should be a neater curve. And goes up to 360. So that's the basic shape of the sine graph, and it just continues like that on and on. However, the question's only asked us to do it between 0 and 360, so we stop here, we don't go onwards. It also says, for part B, find the coordinates of any stationary points. And a stationary point is when the gradient is 0, it's horizontal, flat. And there are two stationary points on this curve. There's a maximum point here, and there's a minimum point here. And the coordinates of this point here, well, the x value is 90 and the y value is 1. So one of our stationary points is 90 and then 1. And our next stationary point, well, its x value is 270 and the y value is -1. So it's 270 -1. And that's the answer to that question. For this question, we need to draw the Cos X graph. Now, the Cos X graph is very, very similar to the Sine X graph, only it starts at 1 instead of 0, 0. So we're going to start at 1. If I go along, I'm going to split it into 90-degree segments again. As I go along 90 degrees, it's going to drop, because what happens here is it's going to drop and then it's going to go back up. So it drops from 1 to 0. Then if we go to 180, it drops to -1. Then we'll go to 270. It's starting to go back up now because it's dropped. Once it hits -1, it needs to go back up. So at 270, it's going to go up to 0. And then at 360, it's going to go back up to 1. So if I'm going to draw this graph, it's going to curve down to 90. It's going to curve to -1. Then it's going to start curving back up to 270 and a curve to 360. So that's our curve for y equals cos x. So you just have to memorise the two graphs, and it's up to you how you draw it out. As I said, I like to split it into 90-degree segments. Others may do something a little bit different. Now, part B says one solution of the equation 6 cos x equals k is x equals 60 degrees. Find the value of k. Now, this is the kind of question that's likely to come up on a non-calculator paper. And we know that x is 60 degrees and it wants us to find the value of k. So I've got 6 times cos 60 degrees, 60. Right, now cos 60 is actually one of the exact values you need to know in trigonometric ratios. So if you don't know your exact values from trigonometric ratios, make sure you learn them. I do have another video on trigonometric ratios if you're interested in looking at that. Now, the value of cos 60 is a half. So you may have learnt it, or you may look at use the special triangles. And so 6 multiplied by a half is 3. Therefore, our value of k is equal to 3. The next part C is find another solution in the range of 0 degrees to and 360 degrees. So what we've done is we've got a value of cos 60. So if we look at the graph, it'd be around, so cos 60 would be around here. And it should really be at a half, but yes, but if we have a look at this graph, there's another value between 0 and 360, which is going to be equal to the same amount. So if we put a dashed line along, it would be here. And in order to find that value, what we would need to do is we would need to do 360 and you can see that it's it would be sort of symmetrical, the graph. So what we're going to, so if the distance from here to here is 60 degrees, the distance from here to here is also going to be 60 degrees. So in order to work out the x coordinate, the x value of this point, I'm going to need to do 360 minus 60, which gives me 300. So my answer to this question is 300 degrees. Question 3 is sketch a graph of y equals tan x. Now the graph y equals tan x does deviate a lot from these other two graphs. It is very, very different. And it sort of splits, it repeats itself in every 180 degrees. It starts at 0, 0 and it curves upwards towards 90. 90 is actually an asymptote. There's no value of 90 degrees. If you type tan 90 into your calculator, you'll get math error. Because what happens is this graph curves upwards, and as it gets higher, as the y value gets bigger and bigger and bigger, it gets closer and closer and closer to 90 degrees, but never reaches it. So after we've drawn it going up towards 90, the next we start down here, and it's a similar shape, and it goes through 180 at 0, and then curves back up. And then it gets closer and closer to 270, but never reaches it. And you get the same thing happening down here. It goes up just like it did from 90 degrees. And this shape repeats itself every 180 degrees. So we could keep on drawing it, but it only wants us to draw it between 0 and 360. Now, part B says one solution of the equation 2 tan x is x equals 60 degrees. Again, this is probably something that would come up on an calculator paper, and you need to know your exact values. The exact value of tan 60 is root 3. So 2 times root 3 is 2 root 3. Which is our value of k. And it says find another solution in a range of 0 degrees to 360 degrees. Well, what we've done is we've got the value at around 60 degrees, which is around here. And what we can see is the graph repeats itself every 180 degrees. So the next value would be around in this area here. 180 degrees after 60. So what I need to do to find my other solution is I just need to add 180 degrees onto 60, which will give me 240. Yes, so that's my answer to that question. The other solution is x equals 240 degrees, because that has the same tan 240 would also be equal to root 3, just like tan 60. And for our final question, we've got this graph here, which is y equals 17 minus cos x, and we've got P, which is a stationary point, the maximum point at the top of the graph. And it wants us to find the coordinates of P. Now what you can see is you've got a minus value, so you know when cos x is minus, a minus times a minus would be a plus, so it's going to be, you're going to be adding values when cos x is negative. And the more negative cos x is, the higher that value that you're going to add on to 17 is going to be. And if we think of the Cos X graph, it looks a bit like this. And the minimum point it goes to is -1, because that's where it's going to be when the graph, when 17 minus 13 cos x is going to be the biggest, is going to be when cos x is equal to -1, because that's the most negative it gets. And that happens at 180 degrees. So we know when x is 180 degrees, cos x is going to be its most negative value. Therefore, we're going to have, to find the y value, we're going to have y equals 17 minus 13 cos 180. And we've said that cos 180 is 0, which we can is 1 minus 1, so which we can see from looking at the graph. Therefore, we're going to have y equals 17 minus 13 times by -1, which is 17. Well, minus 13 times -1 is going to be plus 13. Therefore, our y value is going to be 30. So the coordinates of point P are, well, the x value is going to be 180 degrees, because that's when cos x is at its lowest value of -1. Because a minus times a minus is a positive, that's why we need it at 180. And when we put cos 180 in, which gives us -1, then our y value is 17 plus 13, which gives us 30. So our y coordinate at that point is 30 degrees. Thank you for watching. I hope you found that helpful. If you liked the video and like to see more, please hit the subscribe button. And for practice questions, visit www.mcdonaldmathandscience.com. The link is in the description.